Dear students, today's class let us discuss about the acidity of phenols. So in the previous video we have discussed about the acidity of alcohols. Those acidity of alcohols and phenols can be considered with the reaction of highly reactive metals like sodium, potassium and aluminium. So by the reaction of such stronger active metals, we can confirm that the cleavage of OH bond takes place in alcohols and phenols. So due to cleavage of OH bond, the release of H plus ion takes place in both alcohols and also as well as phenols. So that we can confirm that the alcohols and phenols are acts as acidic in nature. So when we consider the alcohols, when we compare with water molecules or phenols, so alcohols are lesser acidic than that of water molecule, because here alcohols are tendency to accept one proton, which can able to make a protonated alcohol, or alkoxide ion, which is tendency to accept one proton from water molecule. So at that time alkoxide ion is acts as base due to presence of lone pair of electrons on the oxygen atom. So and water is acts as acid. Why? Because according to Brownstein acid base theory, the water molecule which is tendency to donate one proton to the alkoxide ion, so it becomes more acidic than that of the alcohols. So alcohols are more acidic than water, whereas in case of phenols, today's class does consider phenols. So here phenols are stronger acids than alcohols and water. So how these phenols are more acidic than alcohols and water? So because due to the ionization of phenols and alcohols takes place as follows. So when the alcohols and phenols which undergo ionization reaction, so on the basis of this ionization reactions we can confirm that phenols are more acidic than alcohols. So this is the molecule is called as alcohol molecule. This is alcohol molecule. This is alkoxide ion. This is alkoxide ion. We can say that this is hydrogen ion. So cation. So this is called phenol. This is called phenol. This is called phenoxide ion. Phenoxide ion. So when phenol which undergo ionization, that leads to the formation of phenoxide ion and hydrogen ion. So similarly, when the alcohol which undergo ionization, so which when undergo ionization process, that leads to the formation of alkoxide ion and hydrogen ion. Now we can confirm that, so among these two, alcohol and phenol, which is more acidic and why? So here alcohols are having hydroxyl group. So here hydroxyl group having two lone pair of electrons, and here alkyl group is present. This alkyl group is electron releasing group. So whenever the tendency of this alkyl group, which when releases the electrons towards the oxygen of hydroxyl group, the electron density of oxygen is goes on increases, so the release of H plus ion becomes little bit difficult, so that it can undergo ionization in the form of alkoxide and hydrogen ion. Sometimes whenever the alkyl groups are more and more, so the release of H plus ion becomes very difficult. So whenever in the case of phenols, here in case of alcohols after ionization, here the negative charge is there. This negative charge will not be stable. This negative charge of this alkoxide ion, this will not withstand on the oxygen atom, so that again it can supposed to attract with hydrogen atom and it can make a hydroxyl group, or it can again it will considered as similarly it will reverse reaction also. We can consider it is not a stable alkoxide ion, that's why it is unstable alkoxide ion, that's why it will again it leads to the formation of alcohols. That's why we are not considering this alkoxide ion is more acidic. So that's why it is lesser acidic, because more unstable in nature. So whereas in case of phenols, here the hydroxyl group carrying carbon atom or the oxygen atom of hydroxyl group is linkaged directly to the sp2 hybridized carbon atom, is linkaged directly to the sp2 hybridized carbon atom. So already I told you that, so hybridization of sp2, so sp3 hybridized carbon atom is lesser electronegativity in nature. So sp2 hybridization is more electronegative in nature. The sp is still more electronegative in nature. So sp3 is lesser electronegative than sp2, sp2 is lesser electronegative than sp. Means that here due to sp2 hybridized carbon atom, it is little bit electronegative in nature. So due to more electronegative in nature, this carbon atom is tendency to accept or withdraw the electrons from the oxygen atom of hydroxyl group. So whenever the electron density of oxygen goes on decreases, the bond strength between oxygen and hydrogen becomes very weak. So whenever the bond strength is going to be decreases, we can say that in another words, here the polarity of OH goes on decreases due to tendency to accepting the electrons from the oxygen to benzene ring, towards benzene ring. So that's why electron density goes on decreases. So ultimately it undergo ionization that leads to the formation of phenoxide ion and a hydrogen ion. So whenever this bond is going to be cleavage, at that time these lone pair of electrons will shift over on the oxygen atom. So here H plus ion will release immediately. So this phenoxide ion is more stable in nature. So phenoxide ion is more stable than phenol. Okay, so this is the molecule is considered as phenoxide. This phenoxide ion is more stable than that of the phenol molecule. How? We can also explain the stability of phenoxide ion and phenol with the help of the resonance form of phenoxide ion and also as well as phenol molecule. So here phenoxide ion, it is a molecule which is it will withstand the electronegative charge on the oxygen atom. That's why it is more stable. So on the basis of phenoxide ion and phenol, we can confirm that which is more stable and which is less stable. Okay, here the phenoxide ion is more stable than phenol. So in the point of examination, they may ask you like that, phenoxide ion is more stable than phenol, and why? So because on the basis of resonance forms, we can explain the phenol is very less stable than that of phenoxide ion. So here this is the phenoxide ion, resonance form of phenoxide ion. So this is the resonance form of phenol. So why the phenoxide ion is more stable than that of phenol? So for that, let us take the reason. Here the resonance form of phenol can be observed here. Here this is the first resonance form of phenol. So phenol molecule I have written here. So when the electron density of oxygen atom of hydroxyl group, which when tendency to attract towards the benzene ring. So here the electron density of oxygen goes on decreases. So as the electron density decreases, the OH bond becomes weakens. So when these lone pair of electrons are attracted towards this sp2 hybridized carbon atom, so it will get tendency to form a double bond character. Here we are observing when these lone pair of electrons shift between this oxygen and carbon, this will get double bond character, and this oxygen atom will tendency to attain a positive charge. So because due to loss of one lone pair of electrons, it is tendency to attract towards the sp2 hybridized carbon atom of benzene ring. So it gets double bond character and oxygen gets positive charge due to loss of electrons. And next, ultimately this bond electrons are shifted on the next carbon atom. So that charge is considered as electronegative. Why? Because the gain of electrons can be observed here due to loss of pi bond electrons. Here this can attains negative charge. So in this resonance, again if I replace the electrons, here delocalization of electrons takes place within a ring. So that can be observed in 5 resonant structures. So when these electrons are shifted over between these two carbon atoms, so this pi bond is going to be broken, and these electrons will shift over on this carbon atom. This gets electronegative. Again these electrons will shift here, and this bond will cleavage, and the lone pair of electrons will shift here, and again here this bond will shift, and again as usual the original electrons will get back to the oxygen atom, and ultimately it gets again 2 lone pair of electrons. The structure 5 and structure 1 is similar, and these are the resonating structures. So whenever the electron density of the oxygen goes on decreases, the H plus ion can be easily releases, and the why? Because the phenol is less more stable. So phenoxide ion is more stable and phenol is less stable. Why? Because here this phenol is less stable because of this phenol in that phenol molecule hydroxyl group of oxygen atom is carrying positive charge, and here the benzene ring, on the benzene ring we are obtaining the negative charge. So due to presence of dipolarity in phenols, so this molecule which gets lesser stable. So due to presence of positive charge on oxygen atom, so the polarity of oxygen and hydrogen is goes on decreases. So due to decreasing the polarity, so ultimately the OH bond is going to be cleavage, and it can releases the H plus ion as acidic in nature. So it is a less stable in nature due to presence of one positive charge and one negative charge. Due to presence of dipolarity, it is less stable in nature. When we consider the resonance form of phenoxide ion is more stable. Why? Because it does not having dipolarity. So it does not having positive charge and negative charge. It is no separation of charge can be seen in this phenoxide ion. So due to presence of negative charge, here oxygen is also having negative charge. So due to presence of lone pair of electrons, it is electron rich. So that's why it is represented in the form of negative charge. So this is negative. After cleavage of this pi bond, these lone pair of electrons will occupy on this carbon atom is also a negative. So due to no separation of charges, this molecule is resist as so more stable in nature. So that's why here no separation of charge can be seen in the phenoxide molecule, but whereas in case of phenol molecule we can obtain the dipolarity charges. Due to that reason, phenol is lesser stable than that of the phenoxide ion. Okay, now let us discuss about the effects of substituents on acidity of phenols. So whenever if you consider some substituents on phenol molecules, so what happens the acidity of phenols? So whenever if there is a presence of sometimes electron withdrawing groups may be present as a substituents on phenol molecule, and in some other times due to presence of electron releasing groups on phenol molecules. So whenever there is a presence of electron releasing groups and electron withdrawing groups on the phenol molecule, ultimately the phenol acidity is goes on changes. So what happens if there is a presence of electron withdrawing groups like, so electrons withdrawing groups means the tendency of the substituent which is attract the lone pair of electrons towards itself. So for example, the electron withdrawing group like nitro group can tendency to attract the electrons from the benzene ring, and the cyanide, it is tendency to attract the electrons from benzene ring, and halides and aldehyde and carboxylic acids. So these are all the groups which are tendency to accept the electrons towards them from the benzene ring. So ultimately what happens, the acidity of the phenols is goes on increases. So due to the electrons are away from the oxygen atom of hydroxyl group, so that the OH bond becomes more and more weaker. That's why the polarity of OH group is goes on decreases. As the polarity is goes on decreases, ultimately OH bond is going to be cleavage, and the release of H plus ion takes place. Ultimately we can say that the phenols are more acidic when there is a presence of electron withdrawing groups on the phenol molecule. For example, this is a phenol molecule. If there is a presence of one electron withdrawing group, so this is the nitro group, NO2 is the nitro group, is the electron withdrawing group. Whenever if there is a presence of electron withdrawing group, so this group is tendency to accept the lone pair of electrons from the oxygen atom, and this bond electrons will comes here, and ultimately this gets a negative charge. So it undergo resonating structure. So this is the group which tendency to accept the electrons from oxygen of hydroxyl group. So ultimately the electron density of this oxygen atom is goes on reduces. As the oxygen atom of the electron density decreases, here it gets electropositive, so lesser electronegative. That's why this bond is going to be cleavage easily. So ultimately this releases as H plus ion. So due to presence of electron withdrawing groups on phenol molecules, the acidity of phenols is goes on increases. So due to negative inductive effect, we can say that. So negative inductive effect, due to negative inductive effect will form. So due to negative inductive effect. So that can also be written as negative inductive effect. So due to negative inductive effect, the electron density goes on decreases. So ultimately the release of H plus ion takes place. So due to presence of electron withdrawing groups, not only nitro group, either instead of nitro group there may be presence of cyanide, or there may be presence of halides, or there may be presence of aldehyde group or carboxylic acid. So they may ask you in the point of examination. So here there are two molecules. Here OH halide, OH CH3. So among these two molecules, which is more acidic in nature and why? So among these two molecules, which is more acidic in nature? So we have to observe the substituent present on the phenol molecule. Here in this phenol molecule, there is a presence of halide is the substituent. Here the methyl group is not an electron withdrawing group. Methyl group is electron releasing group. So methyl group is an electron releasing group. So after I will tell you what happens if there is a presence of electron releasing groups are present. So here maybe these groups may ask in the point of examination. If there is a presence of these such type of groups, those groups are considered as electron withdrawing groups. If there is a presence of electron withdrawing group, the OH bond becomes very weakens. So due to the decreasing the electron density of oxygen atom of hydroxyl group, so that OH bond becomes weak and ultimately it will releases as H plus ion. So we can say that the substance which is tendency to donate the H plus ions from the substance, then such type of substances are called as the acids. So this is acts as acidic in nature due to presence of electron withdrawing group. So this is an more acidic than that of this molecule. So this is more acidic, this is lesser acidic. So we can clarify on the basis of electron withdrawing groups. So due to presence of electron releasing groups, so whenever phenols, if they contains electron releasing groups, so such as like CH3, methyloxy, amine, hydroxyl group, etc. So in such type of groups, if there is a presence in the phenol molecule as a electron releasing groups, we can say that, for example, shall we consider this is the phenol molecule and this is the methyl group. So methyl group is an electron releasing group. Methyl group is an electron releasing group. Whenever electrons are going to be released towards the benzene ring, so this guards, so electron density on the oxygen becomes more and more. As the electron density which is goes on increases, the bond between the OH becomes more and more strengthened. Due to more strength of this OH bond, no release of H plus ion takes place from this orthocrosal. This is orthocrosal. So this orthocrosal which is having lesser tendency to release the H plus ion, so it is an lesser acidic in nature, we can say that. So here what happens? So when we consider the decreasing order of these molecules, so phenol molecule, so what happens? Phenol is more acidic than that of orthocrosal. We can say that phenol is more acidic. Phenol is more acidic than orthocrosal. So why? Because orthocrosal is having electron density which releases the electrons towards the hydroxyl group of oxygen. Oxygen electron density increases, OH bond becomes more and more stronger, so that no release of H plus ion takes place. Ultimately here there is no presence of methyl group, so this is only the phenol. Phenol is having here sp2 hybridized carbon atom. This is tendency to attract the electrons and OH bond becomes weaker, so release of H plus ion takes place very easily. So that's why it is more acidic in nature than that of this orthocrosal. So let us take the series of molecules. So decreasing order of the acidity of these phenols. So here phenol is greater acidic than that of the so metacrosal. You can take metacrosal. This is more acidic than that of the metacrosal is more acidic than that of the paracrosal. Paracrosal is more acidic than that of the orthocrosal. So this is about the order of acidity of phenols. Here phenol is more acidic than, this is metacrosal. Metacrosal is more acidic than paracrosal. Paracrosal is more acidic than orthocrosal. So here phenol is more acidic than that of all the crosols. So we can say that Crusols are lesser acidic than that of the phenol molecules. So phenol is highest acidic in nature. So whereas in case of here, so due to presence of electron withdrawing group, so due to presence of electron withdrawing group, here what happens? If the electron withdrawing group goes on increases, here this is an para, this is ortho substituent nitro group. So this is ortho, this is meta, this is para, like that. When we consider the acidity in the increasing order of here, let us take, as the substituents are goes on increases, the acidity of the molecule is also goes on increases. So we can consider the acidity in the increasing order of